Hello everyone, I am Vaishnavi Amane. I am here to present our compiler design. Let's now next use information of compiler design. Next use information is a sort of a data flow analysis used in compiler design called the next use information. Can be used to optimize register allocation in a computer's central processor unit CPU. The next use analysis aims to identify which program variables will be used on and should be kept in a register for quick access rather than many in memory. The speed of compiled program can be further enhanced by combining next uses analysis with other optimization like register allocation and new range analysis. For example, use next information. For better understanding, consider given code snip x is equals to y plus z, a is equals to x plus b, c is equals to x plus d. The variable x is used three times this code to store results. Once for the result of y plus z, once for result x plus b, and once for the result x plus d. By removing the load and store operations x in between, the compiler can use this knowledge of optimize the code. So let's now the compiler meet an example produce following code. T1 is equals to y plus z, a is equals to T1 plus b, c is equals to T1 plus d. So this code has been optimized and the variable x has been swapped out with the temporary variable of T1. The optimize can increase the performance of the generated code by lowering number of the load and store the operations. Application of next use information. The allocation register in a computer CPU is optimized using the knowledge from the next use. It aids the compiler in selecting the variables that should be kept in register for quicker access. It can enhance a compiler program's overall performance and lower the number of a memory access needed. It can be used with other optimization including new range analysis to enhance the performance of further. The compiler can produce machine code that is more efficient by using next use information. It used to optimize the register allocation in the CPU to both compiler program performance. It is application of the next use information. So next is algorithm for next use information. Next use information user Hamming coding. With this algorithm that is comprised by using fewer bits to encode it is than its original form. The data produced by compiler can be compressed using Hamming coding, which can be reduced the size of bullet code in speed up execution. Data flow analysis. These approaches is used to maximum the code data flow through program and finds areas for improvement by removing pointless computations or rearranging instruction to better utilize the hardware resources. Data flow analysis can be used to optimize the code produced by the compiler. First is the lexical analysis. Lexical analysis approach is used to examine the organization of the source code and pinpoint the program's token, basic units of meaning such as keywords and identifiers. The initial step in the program is often lexical analysis. Second one, syntax analysis. Syntax analysis, this algorithm, the source code's organization and creates an abstract syntax tree, which the program hierarchical structure. The compiler can provide optimized code by using the abstract syntax tree. Third point,